Welcome. Today, we're going to tackle a common type of math problem that combines two different algebraic tools. By the end of this video, you will be able to solve a system of one linear and one quadratic equation using the method of substitution. The specific problem we'll be solving is this: x plus y equals 100 and x times y equals 100. This is a great example because it connects a simple linear equation with a more complex quadratic one. A linear equation is straight, while a quadratic equation gives us a curved shape, like a parabola. Our goal is to find the point, or points, where these two different types of equations intersect on a graph. This point of intersection is the solution to the system. So again, our objective is to learn how to solve a system containing a linear equation and a quadratic equation. There are several ways to solve a system of equations, but for a mixed system like this one, the method of substitution is often the most straightforward. The method of substitution involves solving one equation for one variable, and then substituting that expression into the other equation. Essentially, we're swapping out a variable for an equivalent expression. This is a very powerful algebraic technique for simplifying systems. Looking at our two equations, which one looks easier to solve for a variable? We have x plus y equals 100 and x times y equals 100. The first equation, x plus y equals 100, is much simpler. Let's solve it for x. To do that, we just need to subtract y from both sides of the equation. So we start with x plus y equals 100. We subtract e from both sides, which leaves us with x equals 100 minus y. Now we have a clear expression for x. This expression, 100 minus y, is what we will substitute into our second equation. Now for the main part of the substitution method. We have our second equation, xy equals 100, and our expression for x, which is 100 minus y. Our goal is to eliminate x from the second equation. We'll replace x with the expression we just found. Remember, the expression 100 minus y is equivalent to x. By substituting it into the second equation, we'll end up with an equation that only contains the variable y. This is the whole point of substitution. It reduces the number of variables to 1. Let's make the substitution. We take our second equation, xy equals 100, and wherever we see x, we'll write 100 minus y. It's always a good idea to put the substituted expression in parentheses to avoid algebraic errors. Now, let's distribute the y on the left side of the equation. I times 100 is 100i, and y times negative I is negative y squared. So we have 100i minus y squared equals 100. This looks much more manageable because it only has one variable, y. Notice that this new equation is a quadratic equation. This makes sense, as we started with a linear and a quadratic equation, and our substitution has led us to a single quadratic equation. We've done the hardest part. We've transformed our system into a single quadratic equation. Now, we just need to solve this quadratic equation for y. Our equation is 100 minus y squared equals 100. To solve a quadratic equation, the first step is to set it equal to 0 and write it in standard form, which is x squared plus bx plus c equals 0. To get it into standard form, I'm going to add y squared and subtract 100i from both sides. This gives us 0 equals y squared minus 100i plus 100. Now we have a quadratic equation. Let's try to solve it. We can try to factor it, but numbers that multiply to 100 and add to negative 100 aren't immediately obvious. When factoring is difficult, or doesn't work at all, we can always use the quadratic formula, which is a foolproof method. The formula states that for an equation x squared plus bx plus c equals 0, the solutions are x equals negative b, plus or minus the square root of b squared minus 4ac, all over 2a. In our equation, y squared minus 100y plus 100 equals 0, we can see that a equals 1, b equals negative 100, and c equals 100. So we have a equals 1, b equals 100, and c equals 100. Let's substitute these values into the quadratic formula and solve for y. Let's finish the calculation for y using the quadratic formula. We have the formula and our values for a, b, and c. So we substitute these into the formula. Y equals negative 100, plus or minus the square root of negative 100 squared, minus 4 times 1 times 100, all divided by 2 times 1. Now we just need to simplify this expression. We can take it step by step. Negative 100 is positive 100. Negative 100 squared is 10,000, and 4 times 1 times 100 is 400. The denominator is 2. Next, we perform the subtraction inside the square root. 10,000 minus 400 is 9,600. The square root of 9,600 is not a perfect square, so we need to simplify the radical. We can look for perfect square factors. 9,600 is 96 times 100. The square root of 100 is 10. So, we have 100 plus or minus 10 times the square root of 96 all over 2. We can simplify the square root of 96 further. 96 is 16 times 6. The square root of 16 is 4. This gives us y equals 100 plus or minus 10 times 4 times the square root of 6 all over 2. Simplifying the 10 times 4 gives us 40. Now, notice that all the terms in the numerator are divisible by the denominator, too. So we can divide them out. 100 divided by 2 is 50, and 40 divided by 2 is 20. This leaves us with our two solutions for y. Our two y values are y1 equals 50 plus 20 times the square root of 6, and y2 equals 50 minus 20 times the square root of 6. We have found the two y coordinates where our line and curve intersect, but we're not done yet. We still need to find the corresponding x coordinates to get our final solution pairs. We have our two y values. Now we need to find the corresponding x values. For that, we can use the simplest equation we have. X equals 100 minus y. We will substitute each of our two y values back into this equation to find the two corresponding x values. Let's start with our first y value, y1, which is 50 plus 20 times the square root of 6. We'll substitute this into x equals 100 minus y. Be careful with the subtraction here. We must subtract the entire expression for y1. So x equals 100 minus, in parentheses, 50 plus 20 times the square root of 6. Distribute the negative sign. That becomes 100 minus 50 minus 20 times the square root of 6. Simplifying, 100 minus 50 is phi. So our first x value, x1, is phi minus 20 times the square root of 6. Now let's do the same thing for our second y value. Our second y value, y2, is 50 minus 20 times the square root of 6. Substituting this into our equation, x equals 100 minus, in parentheses, 50 minus 20 times the square root of 6. Distribute the negative sign again. This becomes 100 minus 50 plus 20 times the square root of 6. Simplifying, 100 minus 50 is 50. So our second x value, x2, is 50 plus 20 times the square root of 6. We've done all the hard work and found both our x and y coordinates. Now it's time to state our final solution. The solution to a system of two variables is a set of ordered pairs, x, y, that satisfy both equations simultaneously. The first solution comes from our first pair of x1 and y1. It's the point, 50 minus 20 times the square root of 6, 50 plus 20 times the square root of 6. The second solution comes from our second pair of x2 and y2. It's the point, 50 plus 20 times the square root of 6, 50 minus 20 times the square root of 6. We can see that these two solutions are related. The x and y values in the first solution are swapped in the second due to the symmetric nature of our original equations. To be absolutely sure, we could check our answers by substituting them back into the original equations. This is a great habit to get into. Let's briefly check the first solution in the first equation. The equation is x plus y equals 100. Substituting our values, we get 50 minus 20 square root of 6 plus 50 plus 20 square root of 6 equals 100. The positive and negative square root terms cancel each other out, leaving us with 50 plus phi, which equals 100. It checks out. You would find the same for the second equation and the second solution. So, let's recap what we accomplished today. We successfully solved a system of one linear and one quadratic equation. Here's a quick summary of the steps we followed. First, we solved the simple linear equation, x plus y equals 100 for x. This was our first step. Second, we substituted that expression for x into the quadratic equation, xy equals 100. This created a new quadratic equation in only one variable, y. Third, because it wasn't easily factorable, we used the reliable quadratic formula to solve for y. This gave us our two y values. Fourth, we plug those y values back into the simple linear equation to find their matching x values. Finally, we presented our two solution pairs as ordered pairs. These represent the 2 points where the line x plus y equals 100 intersects the curve, g equals 100. This method of substitution is a powerful tool you'll use in many different algebraic contexts. Keep practicing, and you'll master it. Thanks for watching.